We want to know what to add to x squared plus 2x plus 3 to get a perfect square. So x squared plus 2x plus what is a perfect square? Well, we can reason this out, and we should fairly easily, if we've done some practice with factoring, recognize that x squared plus 2x plus 1 is a perfect square. It's x plus 1 quantity squared. So x plus 1 times x plus 1 is going to give you x squared plus 2x plus 1. Therefore, what do we add to this expression to get a perfect square? Well, x squared plus 2x plus 3, if we add negative 2, then we get this. And now we have a perfect square. Now, let's do the same thing for 3x squared minus 3x minus 18. We want to get a perfect square. What do we add to this expression? Well, I've taken the liberty of factoring the 3 out, which makes the expression a lot easier. It's more difficult to figure this sort of thing out if you have something besides 1 in front of x squared. So it's perfectly legitimate to factor that coefficient out of the whole expression and see if you get something that's a little more tractable. Well, not sure what to add out here, but to x squared minus x minus 6, we could figure out what needs to be added inside the parentheses, and then we could expand everything back out and figure out what needs to be added outside the parentheses. Inside the parentheses, we have to figure out what we have to add to x squared minus x to get a perfect square. And what do we add to x squared minus x? Well, it turns out it's 1/4, but how do we figure that out? Okay, well, we come down here and look at the fact that we did x minus something times x minus something. Now, it has to be x minus the same thing both times because that's what makes this a perfect square. And whatever we put in here, when we multiply it by x here, and then when we multiply it by x here, it has to add up to negative x. So what do we have to add? Well, it's going to have to be negative 1/2 x, or negative 1/2 both times, so that we have negative 1/2 x and a negative 1/2 x to add here. Okay, that equals then x squared minus x plus 1/4, and of course that's the perfect square, x minus, not plus, 1/2 quantity squared. Now we can complete this back up the chain. Having found this, we see then that we've got to add 1/4 here, which means that what we have inside here is going to have to be x squared minus x plus 1/4. So we have x squared minus x minus 6, and we want to get x squared minus x plus 1/4. So what do we have to do? Well, we have to get from negative 6 up to 1/4, which means that we're going to have to add 6 1/4. Of course, we'd more generally write that as 25/4, but just to make the connection, we see that if we add 6 1/4 in here, then that's going to give us the perfect square, x minus 1/2 quantity squared inside the parentheses, okay, because this is equal to this, which is equal to this. So we can replace this question mark with 6 1/4. But then, of course, what do we have to add out here? Well, we'd have to add 3 times that, which would be 18 3/4. Okay, with practice and doing the problems in the assigned section, you should be able to become fairly adept at this. The thing you want to focus on in both cases is the number that you are going to need in order to get a perfect square on the x squared and the x term is going to be the square of 1/2 of whatever the coefficient of x is. And the book will tell you more, and what we've looked at here will give you the idea. And then I'm fairly confident that you're going to be able to perform the completion of the square in the context where it actually arises.